Hey there! Ever wondered how AI is revolutionizing cancer detection? Today, we're diving into a groundbreaking study that uses machine learning to identify prostate cancer with near-perfect accuracy. No jargon, just clear, deep insights. Let's break it down. Prostate cancer is notoriously tricky. Traditional methods like blood tests, biopsies, and patient notes often miss subtle patterns or overdiagnose. That's where this AI system shines. It's not just accurate, it's explainable, meaning it tells doctors exactly why it makes its decisions. How? By combining two powerful tools, BERT and random forest. Think of BERT as a super-attentive medical assistant that deciphers complex patient notes, picking up on nuances like symptom descriptions or treatment histories. Meanwhile, random forest acts like a decision tree, analyzing numerical data, PSA levels, age, etc., to predict outcomes. Together, they form a model that's 98% accurate at staging cancer, nearly flawless. But here's the real innovation. The team didn't stop at raw data. To handle messy, unstructured text, they used PCA, principal component analysis, which simplifies complex data into key themes, like summarizing a novel into its core plot. They also tackled imbalanced datasets with SMOTE, a technique that generates synthetic examples of rare cancer stages, ensuring the AI doesn't overlook them. And to make the model's decisions transparent, they leveraged SHAP values which highlight critical factors, like a high PSA level or a specific symptom, so doctors can trust the AI's reasoning. The results? Stunning. When combining text and numbers, the model's recall, ability to catch all cases, improved by 10–20% for intermediate stages. For instance, it nailed 90% of stage 2 cases with combined data, versus 82% using numbers alone. This proves that patient notes aren't just extra info, they're vital for nuanced decisions. Why does this matter? Imagine a rural clinic with limited resources. This system could help doctors triage patients faster, reducing guesswork. By explaining its reasoning, it builds trust between AI and healthcare providers, bridging the gap between technology and human expertise. But this isn't just about prostate cancer. Researchers are already adapting this approach for other cancers, proving that AI's future isn't about replacing doctors. It's about empowering them with tools that are both powerful and transparent. So what's next? The field is evolving rapidly. As models become more interpretable and data more diverse, we're moving closer to a future where AI isn't a black box, but a collaborative partner in healthcare. Thanks for watching. If you found this intriguing, hit subscribe for more deep dives into science and tech. And drop a comment. Do you think explainable AI will become the norm in healthcare? Let's discuss. Imagine a world where AI doesn't just diagnose diseases, but explains how it reaches those conclusions. That's the future we're building. And today, we're diving into how researchers are making machine learning models more transparent, accurate, and life-saving. Let's start with a key challenge: cancer detection. Traditional AI models can spot patterns, but they often work like a black box. We see the result, but not the reasoning. That's where explainable AI steps in. Think of it as giving the model a voice to say, "Here, that's why I think this is cancer." One study, led by Dash in 2022, used a technique called stratified k-fold cross-validation to test AI models for cervical cancer. What does that mean? Well, imagine baking a cake and testing it in different ovens, the folds, to make sure it's always delicious. This method ensures the model works reliably across diverse patient data, avoiding biases that could miss cases. But how do we understand what the AI is learning? Enter SHAP values, a tool that breaks down how each data point, like a patient's age or test results, influences the model's decision. It's like a detective tracing clues to solve a mystery. For example, a study by Younis et al. used SHAP to decode